Okay, guys. Sorry for the delayed start. Issues with speakers is, I suppose, not an unusual problem when you're organising these things. So, welcome to the Dublin Google Tech User Group. For anybody who hasn't been here before, we're kind of a group who meets up pretty regularly. There's 3 of us involved in organising it. Myself, Sean Murphy, and a couple of the other lads, Brian Farrell and Owen Bailey, who, for various reasons, couldn't make it this evening. So, that's not cycling through the slides, is it? This session is being recorded, as you can see. Just go through the agenda briefly. So, the focus here tonight is a discussion on web frameworks, in particular Python, Ruby, Node.js. I'm sure there will be some questions asked about why we chose these particular technologies, and the answer is that it was somewhat arbitrary. We thought that they're arguably a little bit newer than Java and PHP, or the behemoths, I suppose, that people are saying why weren't they mentioned. These are technologies that we thought more people are asking questions about and are interested in. We didn't have time or scope to cover everything, so we just said we'd limit it to these 3. So after that, then we have a bit of a break, and okay, so we have Alan has just arrived, so we're good to go. So after the death match, or battle of the backends, as it was called at one point, we have a break, and then I'm going to give a short report on Google Developer Day in Berlin. There's 1 or 2 announcements at the end, which will be short. And then we go for a pint in the schoolhouse for anybody who is up for it. So I suppose, so the session's been recorded. That's one thing that we need to say. It's been, this video feed is what's been recorded. Hashtag Dublin GTUG if anybody wants to put stuff out on Twitter. And we've finally consolidated all our online resources to dublingtugs.org. So we've got our Twitter and WordPress and et cetera there. So if you want to get in touch, you can go there. So I suppose just do you want the guys in the panel then want to come up and sit down, so at least people can see your face. So Joe Drumgoole has kindly agreed to chair the panel. Joe, I think, is supposed to be very well known in technology circles around town for quite a number of reasons, I suppose. Joe's Joe's got a lot of experience in the both technology and business space and multiple facets of it around Dublin. Alan Kennedy is going to talk for the Python corner. Alan's been working with Python for a number of years, I'm sure. He's one of the main Python guys in Dublin here. Dec McGrath, I suppose everybody would recognise him as Ruby Ireland, the Irish penguin, with his other hat on. And Richard Rogers has been working with Node.js for quite a while. So I'll hand it over to you, Joe, and you can start the ball rolling.
Great. Thanks very much, everybody, for coming along. I think we're going to just get a quick couple of minutes, 10 or maybe even less, from each of the panelists on the 3 frameworks. From my own perspective, yeah, Java and PHP. Java is kind of old, and PHP is kind of a web framework only. And we really want to talk about back-end systems that are in currently use or up and coming. So, who's ready to go first?
Yeah, I can.
Declan, take it up there.
Yeah, how does it all work? Slides and things like that. So, oh yeah, cheers. So, whoa. So basically, thanks for having the battle of the backends today, and thanks to Sean for kicking it off. Not going to waste the 10 minutes going on about that. So I'm here today to talk about Ruby and Rails. You can see the presentation there. It's why Ruby and Rails. My name is Declan McGrath, as Sean said. I'm the Irish Penguin on Twitter, and I'm a Ruby developer and do a lot of stuff with the Ruby community. And I work on a lot of Ruby projects. Probably the most interesting at the moment is ToothSuite, an online service for dentists to manage their patients, which is a lot of Ruby goodness. So the title of the presentation is Why Ruby and Rails. The why isn't actually a typo. That was deliberately put in there. Why Ruby? Why would actually be one of the characters in the Ruby community, and I think he kind of sums up quite well, what makes Ruby community really interesting and really fun to be a part of. His handle was _y, and of course there's been lots of people in the Ruby community. There's been Mats who invented it. You've got DHH who invented Rails, and we'll come to them in a while. But first, Y was this guy who, he was many things. He was a cartoonist, an illustrator, a programmer. He wrote tutorials. He showed people how to really learn Ruby and Rails in a really fun way. And this is kind of a tribute to him to have _y in the title. So, might just move on there, Sean. Spacebar. So that's about why. So we'll quickly fly through this kind of thing. So we got 10 minutes. So history time. Where does Ruby come from? Ruby comes from Japan. It's really interesting the fact that it comes from Japan because it explains a lot of the things that go on in Ruby. It was invented by Yukihiro Matsumoto in February 24th, 1993. So as you can see there, it's been around for quite a while. And Mats went on to state that the reason he invented Ruby was that he wanted a language that was more powerful than Perl and more object-oriented than Python. That's why he decided to write his own language. And there's the first slight dig of the evening. We should have got some Perl guys in. But on a more positive note, one of the things he said, at Google Tech Talk in 2008, Matt said, "I hope to see Ruby help every programmer in the world to be productive and to enjoy programming and to be happy. And that's the primary purpose of the Ruby language, over all other things." It might give you some insight into Ruby. So what about Rails? Rails was invented by David Heinemeier Hansen, who's known as DHH to most of the community. Rails was extracted out of a Basecamp project called Basecamp, which you're probably all quite familiar with, 37 Signals, who went on to superstar fame. And he released Ruby on Rails in July of 2004, and commit rights were shared as an open source project in 2005. So what makes Ruby really, really interesting? Okay, so Ruby's a multi-paradigm language. There's a lot of languages are really good at OO, are the really good scripting languages, are the really good functional programming languages. What really makes Ruby interesting is that it's multi-paradigm, particularly in terms of object-oriented, and also brings in a lot of functional programming aspects. So just a quick example of functional programming, just a very basic example of kind of what it means. Traditionally, we've thought about object-oriented programming and reusing code through object class hierarchies and objects and things like that. What makes functional programming so interesting is you can kind of go sideways. You can reuse pieces of code, like the strategy pattern. You're reusing algorithms. So without even looking at this in detail, this is a block in Ruby where between the two and the end tokens, you have cars. You iterate through each of them, and it's very straightforward. It's very pleasing and visual in the eye, and it kind of looks quite nice. And you can take a block like this, a block of code. You can convert it into an object using a proc or a lambda, and then you can pass it around. And that's at a simple level all functional programming really is. Ruby really, really does well at bringing in functional programming, and a lot of people really like it because you can do a lot of OO stuff, but you can jump to functional programming when you want. And I've a good friend who's good friend Jose, who's out there somewhere, and one of the things he said was, you could give me any language you want, but as long as I can take a function and pass it around like an object, I'll be happy to do pretty much anything I want. And I think that kind of neatly sums up what's really, really cool. So one of the interesting things about Ruby against other languages is that you can put any code you want in a block or in a proc or in a lambda, as many lines as you want, any sort of expression, and any sort of code. So that's one of the kind of powerful features about Ruby, and you can convert blocks to procs or lambdas and pass them around and make use of closures and things like that. So Ruby, pretty much everything is an object in Ruby. It really, really loves objects. Even classes are objects in Ruby, but we won't really go into that right now. If you look at something like a print statement, print doesn't float around in the ether as a wart in the language or anything like that. Print lives somewhere. It lives in an object. It lives in the main object. This is why Ruby is very self-consistent in the way it's designed from the grassroots up. It is very, a lot of people say pure. It's very pure from the grassroots up. Things a great book, Meta Programming Ruby, if you're interested in reading anything. It explains an awful lot of these constructs and the way they work. And from the ground up, it's very, very elegant. So if you look at something like print, well, where does print live? Well, print lives in the main object. So if you're in the scripting world, you tend to use a lot of kind of floating keywords like that, but they are actually on an object. They do actually make sense from an OO perspective. And this kind of makes a quite nice seamless transition between the scripting world and the actual application world. So if you start off with scripts, you can actually grow them into applications quite easily because there is just a rich amount of objects available and techniques. And this makes mesh programming really easy. So for example, the whole everything in object, if you take integers as a really simple example, or fixed nums as they are in Ruby, you look at them and you think, what could you do with an integer? Would an integer be an object or is it a primitive? In a lot of languages, it's a primitive. But in Ruby, you can take an integer and start adding methods to it. So for an example is in Rails, you can go, when you're setting up your tests and things like, you can go 1.minute.ago. That kind of sounds a bit weird. And it brings in some of the concepts we're going to talk about a little bit about DSLs. But you can reopen pretty much anything and do whatever you want with anything. And that makes mesh programming really easy. And because of the rich object-oriented nature of Ruby, a lot of people consider it quite pure. So one way is never enough. In Ruby, one of the defining features against other languages is that Ruby tends to have more than one way to do things. And that can really piss off people and can make people quite happy. The really good thing about it is that DSLs demand it. So DSLs are basically a domain-specific language, and if you're looking at them, you're talking about giving a rich syntax to the person that's consuming maybe an API or something like that. So if you look at that particular person, you can say to them, let's say take a standard library method. You can alias that method and give it a nice meaning in the world. And one of the places where Ruby's really gaining traction is around DSLs and system admins in their scripting toolbox to do things like this. And things like Chef and Puppet are really starting to gain a lot of traction because of that. Okay, so how are we for time? A few minutes, that's a lot of time. So we'll talk really about Rails, because that's, in terms of the back end, we've gone through Ruby, now we're on Rails. Okay, Rails came out in 2005, 2004, something like that. It was revolutionary at the time. Web development was awful back then, really, really awful. So it brought in MVC, model view controller, separation of presentation and concern. So you've got your models sitting on top of your database, sitting on top of your domain logic, and then in front you've got your views, your presentation logic nicely encapsulated there, and controllers gluing it all together. And what did the controllers do? Well, at that time, when a URL came into a browser, people were like, oh my God, I have no idea how to parse all these parameters. I can't have a sensible URL. I don't know how to do this in a sensible manner. And then came the Rails routing system. And that was a really neat, tidy way. And again, a DSL, a nice way to express something you want to configure or some flow of work you want to do. So between root and REST for representational state transfer, REST took web pages and said, we've got resources, not web pages anymore, not callbacks, not code behind, not all these silly spaghetti junctions over and over again. So between the MVC, the routing, and the REST, you had resources. And when you've got resources, you can start doing really cool things. You can say, basically, I've got this particular resource in my system. I can create it, I can update it, I can delete it, or I can read it. And that meant that your web application and your API were kind of seamless and worked quite nicely together. Active record, love it or hate it, it was one of the things that probably got most headline attention when Rails came out. It pretty much showed a lot of people how to, with very, very little in terms of configuring and giving a very rich query syntax. Active record really made object relational mappers and put them on the map in a big way, in a big, lightweight, agile way. At the time, JavaScript was kind of used in horrible, horrible ways. Rails really jumped on the prototype bandwagon, embraced JavaScript, brought JavaScript in, made it really first-world construct of web development, and now we've moved on to jQuery, and jQuery is even in a gem. And it made the composable UIs on web applications and really rich functionality a real possibility. And then packaging up a library code, you could put it in gems, within seconds you're deployed and you're in the cloud. So that, and the last thing is with things like patterns, dry, don't repeat yourself, not just in your code, not just refactoring, not just using composed meta patterns, but actually to go and dry up your configuration. So you choose a way and you stick to it, and you don't have 50 billion XML files everywhere. A quick word on deployment. On Rails, it's just so easy. It's slick. You've got Git for everything. It's very Git focused. You've got engineered. You've got Heroku. If you want to find your Heroku, get on a plane to go to San Francisco. If you want to find engineered, just turn at the end of the block and go into the next building, and they're down there, and they'll be glad to talk to you. All you really do is you take your project, you Git in it, you have an account in these guys, and you push it, and it's there. And that's you started in 5 or 10 minutes. And they really are very scalable. They really they really use real best practices in terms of cloud deployment. So the future of Rails, well, it rocked then, it still rocks now. One of the big things, as anyone from Google here knows, they brought us Google Maps, where you took images and loads of HTTP connections, bring something down, so they glue them all together, image, 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 image. And then you pull it down and you use CSS to chop it up. And Rails 3.1 has brought the asset pipeline, as they call it, for JavaScript and CSS really to the fore, giving you a way to do it in a really, really easy way to integrate it into your application. It's still trickier than some other things in Rails, but compared to otherwise doing it, it's very, very, very useful. One way to speed up requests is to send them before they're finished building. So they've got HTTP streaming in Rails. So that's coming in 3.1, which means that you can, in certain situations, you can flush out things down to the client and you can start having your web page rendered before it's actually finished on the server. Mountable engines are like mini apps, and this kind of comes into a lot of the rack stuff as well, where you can take your application, decompose it into little different units, and have little mini apps with their own routes, with their own configuration and things like that, and you can bring them all together in mountable engines. So, in conclusion about Rails, rather than boring you about things, I'm sure we'll have plenty of debate in a little while about various aspects of it. And the thing about Ruby is it really makes web development fun. If you look at things like where Rails came from, probably the reason that DHH picked Ruby as a base language is that the meta-programming features that you see make building frameworks easier. And that's one of the really important factors. So just the last thing I'll leave you with is just a couple of quick resources. RubyIreland.com. If you want to check it out, that's where we all hang out. The Google group in Ruby Ireland is the best place to be. It's probably where all the action happens, although maybe one post a week. For Windows, there's been a big effort in the Windows installers lately. Traditionally, it's been a Linux and Mac loving, but engineered and a guy called Wayne E. Sigwin, he's done massive, massive work. And the Rails installer at railsinstaller.org, if you want to check it out, 70,000 downloads on Windows already. And if you want something lighter than Rails, something where you're wrapping more of an API and you don't need all the front-end heavyweight features, you got Sinatra. Sinatra's just a light version of that. And it's not quite a resource, but I threw it on the slide anyway. Thanks very much for listening. My name has been Declan McGrath, again, the Irish Penguin. And it's coming up to the end of Movember, so if there's anyone out there doing the Movember, I see like a ridiculous amount of mustaches out there. Yeah, go and give to those people now. And if you don't have a friend that's doing it, just give it to me. Thanks very much. Cheers.
Thanks very much, Declan. So, are we going to get Alan up next?
Yep.
Who's ready to go? You've got to get a slide. While we're getting that up and running, Declan, couple of questions that came to mind there. It's kind of the new kid on the block. Tell me a little bit about performance.
Do you want the mic or? But this one?
Yeah.
Oh, it's gone.
That way I can give you grief.
Oh, cool. Yeah, so in terms of performance, if you look at, there's two aspects. There's Ruby and there's Rails.
Yeah.
So Ruby, there's been 187, 192, and 193. And in each release, it's made massive performance gains. So if you look at something...
So it must have started out pretty slow.
What's that?
So it must have started out pretty slow.
Not necessarily. I guess we look at Java now and we say Java is pretty competitive in terms of speed. And certainly, all those years ago, people said... Java can never compete with like C++, the same way as the assembly people said it before then. Things get faster and faster all the time as things mature. And, depending on your needs, if you Ruby 193 is much, much faster, and Rails sitting on top of it is faster as a result. If you're doing web apps, I would certainly think that Rails is going to be completely and utterly performed, which isn't a real word, in terms of actually delivering you your web application. It's been used in so many big sites. It's used in Groupon. It was used in Twitter for such a long time. The key there is caching. So in terms of your web, yes, you want to cache, but you want to do that with any language. Cool. It's pretty quick. And in terms of backend stuff, maybe if you have a backend, a real engine, a real greyhound in the back, maybe Ruby isn't the best choice. But it's definitely got faster and faster. And my understanding is it's got parity with Python pretty much now at least.
Right, Alan.
Hello, anybody hear me? Yeah? So, my name's Alan Kennedy. I'm a Python committer. I've been using Python for about 12 years now. I was partly involved in the Wsgi effort as well, if anybody knows what that is. And I'm going to try and cover in 10 minutes some useful stuff for you to know about Python. Next slide, please. Python was the first ever, the first... Steady on. The first sort of framework for web publishing was written in Python. It was Bobo, Jim Fulton's thing that turned into Zope eventually, first written in 1994. And basically what that was about was putting object graphs and mapping URLs to object graphs. But they also tied it up with an asynchronous database and an asynchronous request handler, network protocol handler. So it was actually quite a complicated thing. And Zope was one of those things you either loved it or you hated it. And if you loved it, you knew everything that you needed to know about it. Apart from that, there were a lot of competing frameworks in Python. There was Caragel, there was Cherry Pie, there was Quixote. There was all these incompatible systems. They all used a different linkage model. They all use CGI, some of them use CGI, some fast CGI, some mod Python. Some had their own servers, some used their own protocols. And this was a very complicated world indeed, because it meant that you couldn't take a component from one web application and transfer it over to another, because they used different request objects, different linkage models, different everything. So basically, before WSGI, you had to pick your framework and pretty much stick with it. So then along came WSGI, which was Philip J. Eby, some of you may know who he is. So that the whole web world needed unification in Python and came up with WSGI and led an effort back in 2004 to standardize deployment, standardize the link between the application and framework and the server that it was running on. And that pretty much succeeded. He had higher goals for it than actually got achieved, but what did get achieved was very, very good. So what it means now is that you can write your application or framework against WSGI and run it on Apache, run it on Tomcat. You can run it on different versions of the interpreter, which is an important thing for some people. You can run it on Jython, which means you can run your Django programs, for example, applications inside a Tomcat container, JVM. Iron Python, you can do the same with the Microsoft.NET stuff. And PyPy is very much up and coming. I'll talk a little bit about PyPy later on. I suppose the most important thing to WSGI, it makes testing a whole lot simpler, because it simulates a server environment it simplifies the server environment so much that it's really easy to mock up. So you can create sort of faux containers, mock containers to contain your application and test it really extensively. Also makes portability easy, obviously, if you can move between containers. And I suppose the most important thing to note about its success is that it's been adopted by other languages. Ruby has adopted it with Rack, Perl has adopted it with Plack, JavaScript adopted it with JSGI. So it was obviously a good idea, and everybody's jumped on the bandwagon. But it came from Python first. So rather than talk about languages and why Python might be a nice language to write, probably not too productive. I'd imagine a lot of people here have probably written a lot of Python and probably know quite a lot of Python. They don't need to be shown any. So what I'm going to try and cover now is what I think is required for a modern web framework. What are the things that, if you're going to be writing a web application or a network application of some form, what are the facilities that you need in your framework in order to do a good job as quickly as you can? So ease of use. Everybody wants it to be easy to use. Everybody wants to sit down at a tutorial and 20 minutes later have a blogging application running. And that's fine. That's absolutely fine. It should also have a shallow learning curve, in that I should be able to sit down with it and do my simple blogging application and not have to learn how to maybe persist my blog posts into a database until later on. I'll just persist them in the file system for now. So I learn incrementally. But it also has to be powerful. It has to do all of the things that I need it to do. If I've got to integrate with my enterprise systems, if I want to have it generate multiple formats, these things should be easy to do as well. So it has to be powerful. And flexible. Flexible meaning that it can output all kinds of formats, it can process all kinds of inputs, it can work in any region of the world for any person's language, those kinds of things. So, in summary, everything in a bucket with a fried egg on the top, and don't skimp on the pate. So, the the first thing, and this is something that Declan touched on with Rails, is mapping URLs. To me, this is the key component of any web framework. Consuming URIs, which is where you're taking a URI request from the HTTP request and turning it into a call to whatever functionality you've decided is going to service that request. So do you want that to be in line with your code? When you're writing your code, do you want to have to put annotations or decorators onto that code to say, this is an entry point for my web application? Or do I want to have a map? Do I want to set up a dictionary that has a load of names and maps that to callable objects? And Python doesn't really make a differentiation between functions, classes, callable objects. Everything is callable. So you can have a mix of callables. For example, you could have a mix of functions, a mix of objects, classes, callable classes, generators, iterators, whatever, to implement your functionality. Or do you want to have the whole thing separated out into a configuration file? Now, I'm not going to tell you what the answers to these questions are, but I think these are the sort of questions you need to ask about any framework to see if it does things that in the way that you would like them to be, and for it to be maintainable, easy to read, and all those things. In Python, just going back briefly, everything is a callable. Everything should be a callable. Everything is a callable. You can call anything you want just by putting a call method onto it. So that's a nice unifying principle. Fungibility. Objects can be interchangeable. The more important thing about URIs is being able to generate them, because, and this is going back to what Declan mentioned earlier on about composable applications. I mean, the way that we are in the world these days is we don't want to present just a single application generally. Sometimes it's an entire portal. We've got multiple applications that need to interact, but they're still implemented in separate application code bases. So being able to go to an application and say, I want a URL that indexes back into that blog post so that I can publish that URL. And here we're sort of getting into REST, hyperdocument style interfaces where you return a resource that contains embedded URLs that index back into the application. I won't go into that too much, but reversibility of URIs is very important. And that's what I just talked about. And when you want to have cross-application URLs, you have the same problem again, only more so, because perhaps your other applications are not even written in the same language. So these are the concerns about where do you want your URI mapping to be? Do you want it to be in your code? Do you want it to be in a config file? How are you going to generate them? Another thing that isn't big at the moment, but will be big in the future, internationalized domain names. So whatever component you use for generating URIs and consuming URIs is going to have to understand IDNA. Unicode and path names, same thing, using non-ASCII characters in file names and path names. These things have to be dealt with seamlessly, and sometimes browsers do things differently. You need a framework to understand and make the right decisions based on what the browser agent is, and so on. Same goes for parameters. Form handling. Probably the most important thing one of the most important things that a web framework does, and that's processing the user input, and it can come in a lot of different ways, and decisions have to be made about it on the way in. The query string parameter is one of the ways. Post data. Sometimes if you leave off a form encoding on a form and you send it back to the browser won't actually supply the form encoding to you when you send it back. Therefore, your framework has to know this particular browser sent it, and we know that it defaults to a particular character set, or by previous interactions, we know that it's used a particular character set. Also very important is that it protects you against things like CSRF attacks, cross-site request forgery, whereby somebody I won't go into the details of it, but you can protect yourself with a proper form handling mechanism that knows what a CSRF attack is. So if the framework takes care of it, then you don't have to. Encoding attacks is another possibility. UTF-7, you can sneak in meta characters in UTF-7 that don't look like the plain character that they are when you represent them as ASCII. And then newer threats, homoglyph attacks are probably going to get bigger and bigger. German SSET happens to look exactly the same as a Greek beta, and the eye wouldn't notice, but a computer would, because the code points are different. So having your web framework handle those kinds of things could be important in the future as well. On the internationalization front, Python has excellent support for transcoding, always has. Probably second only to Java, I would say. I should say as well, Python, I think, is the oldest language that we're talking about here as well. First written in 1989, and has had Unicode, full Unicode support since the year 2000. I'm not sure about the other languages in terms of being able to express non-ASCII literals, like strings of actual Unicode characters in your source files, but Python does support that, which makes it very easy for non-native English-speaking programmers to, work with things. CPython has a very complete UCS2 implementation. I'm not going to go into the detail of the differences of UTF-16, UCS2, but basically UTF-16 is Java's choice and .NET's choice, so Jython and IronPython inherit those. CPython sticks with UCS2, which limits it to a small degree, but the support is pretty excellent. Session handling, very important thing. Everybody uses sessions at some stage or another to store preferences or history or authentication, authorization, whatever. But one of the most important things about session handling is, can you turn it off? If you're working with a REST system, you don't want a new session to be created every time you have a new request or a new user, because it's just not scalable. You have to get into clustering on the server side. Maybe if you want to handle thousands of users, you have to have a shared store, whereas with something like REST, representational state transfer, all of the context necessary to service a request comes with the request. And so for that particular case, you need to disable sessions. And that isn't always easy in some frameworks. Session hijacking is obviously another security concern. Caching, this is one you touched on earlier on. Caching is, a way to get expedient scalability. If you put a cache in front of your application and there's only a load of read requests coming in, you can get massive increases or decreases in response time, handle much more load. But it's very important that your web framework allows you to interfere with the caching mechanisms. My understanding of Ruby on Rails is that it doesn't. Actually, I want your advice. I'm running a Redmine Ruby on Rails application, and I can't get it to stop emitting the cache control headers. It insists on not letting me cache stuff. And does the framework come with built-in caching support? The Django framework has memcached. Built-in support for memcached. You have to supply the memcached yourself. Authentication authorization. Is the framework going to do these things for you? Because if the framework's not going to do them for you and you have to do them, then you have to do them yourself. And if you're working in an enterprise or other scenario where there's a lot of users involved, you might have to integrate with an identity store, LDAP, Kerberos. So whether your web framework has out-of-the-box integration for these things is an important choice. If you're not going to do authorization, then you need to model your own permission system. The last major area, which is templating. In Python, like in all dynamic languages, it's extremely easy to create your own templating language, and everybody does. Everybody goes away and creates their own and won't use anybody else's sometimes. There are literally 1,001 ways to do it. So if you're going to pick a framework and it ties you into a particular templating language, then maybe that's a bad thing. Maybe you want to have interchangeability. When we're talking about web applications, it's very much a case of generating textual formats, HTML, XML, JSON. I'd make the argument that if you're generating HTML or XML, then you need to be using an XML-specific templating language because it understands the escaping concerns necessary. Sure. 10 seconds. Okay. So, and security again. So, I suppose in summary, what I would say is Python's got a lot of web frameworks. It's got some frameworks that integrate everything, the Django framework does all of the things that I mentioned to you earlier on. There are other frameworks, smaller, pyramid, flask, bottle, that permit you to supply your own components and integrate them in whatever way you see fit. But you will end up implementing some of those concerns that I've gone over in the slides here today. Thanks.
Alan, thanks very much. And now the new kid on the block, Node and JavaScript, and we're going to have Richard talk about that. We have a deck ready to go. Look at that, excellent.
Thanks, Joe. Thank you. So, my name is Richard Roger. I'm here today to introduce you to Node.js. Just as a matter of interest, who here has actually used Node.js? If you could stick your hands up, it'd be kind of interesting to see. That's pretty good. That's pretty good. Let's pop on the next slide. So, the thing about Node.js is it's server-side JavaScript, which in a way sounds like a new idea. It actually isn't. Netscape was doing it back in the mid-90s. I remember in '98 looking at one of their implementations and going, oh my God, you're using JavaScript, a toy language, on the server side. Are you crazy? There's this other cool thing called Java. Why are you not using that? And I was right for the next 10 years. I suffered for it, obviously, but anyway, the sooner I forget my Java nightmare, the better. The really cool thing about it is it's not just JavaScript on the server side, because that's been done before. You had Rhino, you had SpiderMonkey, a whole bunch of different stuff. What Node.js is the Chrome V8 JavaScript engine on the server side. So what it is a really cool, just-in-time compiler that takes the JavaScript code, turns it into machine code, and optimizes it. It has generational garbage collection. It even generates virtual classes on the fly to optimize any object-oriented code that you're writing with JavaScript. The net result of that is it's just really, really fast. And with all due respect to the other things that the other frameworks do, all I care about is speed. Well, I care about speed, and I care about not getting phone calls at 4 a.m. because the server has fallen over. And Node's also actually pretty cool at that. So that's really cool. But there's another side to it as well, which is even more revolutionary. And that's the fact that the code itself is non-blocking. And that means that the way that it deals with concurrency is much, much simpler than something like Java, for example. There's only one thread that you as a developer use. Node.js itself has a bunch of threads that handle I/O and all that sort of stuff, but you as a developer only ever have to care about one thread of execution. Coming from the Java world, I'd often find myself in the last year looking at a line of JavaScript code in Node going, what if somebody else modifies this on me? And then I'm thinking, no, I don't have to worry about that. It's not going to get modified. That's really cool. It's also a little bit dangerous because if you tie up the CPU, that's it. No more requests are going to get served. But it is a really, really great way to build really fast servers. The other side of that is it necessitates an event-driven approach. So what you do is you wait for events to come in, and you deal with them as they come in. And what that means is instead of having a whole bunch of threads, or a thread per request, or a thread pool, every time an event comes in, Node delegates to your code does a bit of work. And for example, you might get a HTTP request in to get an object from the database. You're going to throw it back as JSON. You look at your URL, you ask the database for the data. At that point in time, you're done. Node goes back to waiting for another HTTP request. Another request comes in, might be for a static file. You ask Node to go to the file system, and you're done. So now you're waiting for a file, and you're waiting for the database. The operating system comes back with the file. You get the file, you throw it back to the client. Another few seconds, milliseconds later, the database comes back. You throw that back to the client again. Everything happens in sequence. There are no threads, but it all happens really fast because most of the time You're just waiting for some other resource to give you back some data. People often ask me, what is Node good for? What can you do with it? I thought I would put up a couple of the projects that I worked on this year just to show you that it is pretty general purpose. First one is the Sunday Business Post website and mobile apps that went live a couple of weeks back. That entire system, every single line of code in that system is written in JavaScript, all the way up from the servers to the web to even the mobile native apps. In fact, the fact that you could do it in JavaScript is really, really nice because you don't have to swap and change. It's all one thing in your head. And that's an example of a pretty straightforward e-commerce-based, high-profile, high-load site, multiple virtual machines, all that sort of stuff. Another one I worked on for an American startup, Stanzer.com, is a classic Node application, real-time chat using WebSockets. One of the things Node was originally famous for is that it could do that really, really easily. And again, that goes back to the event-based approach. Chartica.com is a little sort of startup experiment that I'm running, which is real-time analytics. The whole thing, which handles a whole bunch of requests, pretty much, I'd say over 100K a day, runs on one Amazon microinstance. That's pretty much it. And that shows you how efficient Node is with your CPU. Another thing that I worked on was for a research institute in the States. And this is something completely different from a web app. This is talking to hardware devices using Telnet, controlling infrared cameras, checking vibration sensors on pylons, all that sort of stuff, aggregating the data, doing a whole bunch of batch processing, generating graphs, all that kind of stuff. And Node can handle that really, really well as well. And all those things, in terms of developer productivity, they were really great. They're really fun to do. You weren't really fighting the language or the system. They went really smoothly. Just to give you kind of an example of the peace of mind that Node can give you. This is one of those sites. I'm not going to say which. Running on Amazon, a whole bunch of virtual machines, small virtual machines, Amazon load balancer, fairly standard setup. At the bottom, you can see requests coming in. Those are daily. You can see there's a bit of a spike on a weekly basis. You can see the load balancer latency, which is the amount of time it takes for Node to respond to Amazon's load balancer. Ignore that spike. That was Amazon, not me. And at the top, the most interesting one is CPU usage, right? And I think what's interesting about this is that there's pretty much a linear relationship between the number of requests and the CPU usage. And as a sysadmin I used to know very well used to say, those machines are barely scratching themselves. They just don't have to work. You can get so much done. You could push them really, really hard. On Amazon, on a lot of cloud hosting environments, that's actually really important because you pay for CPU time. So it keeps your costs really low. I just want to show you some code. These guys showed you some code, so I can get away with it as well. What I'm showing you here is the basic kind of structures that you'd see in Node.js code. You ask an API to do something, and you give it an anonymous callback function. It returns the data that you were looking for, and you keep going. And you end up with a whole bunch of callbacks. The main idiom is that the first parameter is usually an error object. And if there's an error, then obviously you stop what you're doing and log it or whatever. Let's go on to the next one. I think the big idea with Node.js is that it gives you two things. It gives you cognitive scale, and it gives you industrial scale. Industrial scale is the easy one, right? Lots of power, lots of speed, doesn't take a huge amount of machines to run a really high load site. That's pretty much proven in the wild with Node these days. Cognitive scale is something that Python and Ruby also give you. And it means that it's easy to build big applications. I suppose the way to think about it is this, right? If you take the integers, 1, 2, 3, 4, right? They're really cool. It's a great number system. You can get very far with it. The problem is you can't do orbital mechanics. You can't do quantum mechanics. You can't do string theory. That sort of stuff takes something like complex numbers. Complex numbers are a little bit more complex. You have to put in a tiny bit more effort, but you get a lot more cognitive scale. For just a little bit of extra complexity, you can do a whole lot more. That's the way to think about Node. The callbacks suck. They do make your code a little bit nastier. But the reward is you can do so much more. You get both the speed and speed of deployment and the speed of development. And I think that's the kind of killer thing about Node. In terms of the community, it's a really, really friendly community, and I think it kind of shares that with the other two. You can jump on the IRC channel. There'll always be a whole bunch of people that'll help you. The Google groups are active, Stack Overflow, everything's there. If you're on GitHub, it's really, really easy to commit to all the different projects. I found a bug in Node.js itself a couple of months back. There wasn't any issues. You know, your contributions will be accepted and appreciated. In terms of cloud hosting, there's a whole bunch of options. Heroku, all those guys. Let's move on to the next one. So, to sum up, the good bits are it's JavaScript. Your developer productivity is high. Performance for your CPU is really good. And it's the next big thing, right? That's really important. Get on the bandwagon. On the other hand, it's JavaScript. Callbacks, 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 callbacks. Windows support is not cool. Also, you'll get fired if it goes down and your boss says, you use what? I haven't heard of that. And the last slide. So use it when you load JavaScript. When you want to keep your cloud costs down, when you need to deliver something fast, and you want to do some real-time stuff, where that means web real-time. And I'm wearing a suit because I'm trying to sell you a book, by the way, about Node.js. If you want to learn more, go and read that. Okay, thank you.
Okay, folks, thanks very much. I think we got a pretty good overview there. I'll lay my heart on my sleeve here and say in the past I've used Python, and the company I'm currently working for is an avid fan of Node.js, and we're re-implementing the whole back end in it. But everybody I meet wants to write code in Ruby on Rails. It's definitely the most popular language I've come across. And I think we might start a quick panel discussion with that before we throw it up in the audience. Tell us a little about popularity and what that means for adoption in the various worlds that you live in. Start with Alan.
We need amplification. In terms of popularity, I suppose it's purely anecdotal, but what I hear is that when you go looking for Python people, they're easy to find. When you go looking for Ruby on Rails people, they're hard to find. That's just a straw poll kind of. That's what I've heard from shops that are using Ruby on Rails. They can't get the people. But you know, maybe that doesn't apply to an audience like this who are pretty much happy to choose whatever technology they want to use and learn it and go with it. So,
Declan.
Yeah, I think actually probably what Alan said is a pretty fair reflection there. It probably is harder to find Ruby developers than other types of developers, you know, at the moment. Partially because I suppose Ruby's come more on board in terms of using it for sysadmin and for configuration around that a lot of the Ruby people I know that used to be freelancers have been sucked into some of these bigger companies out there. And they're doing a lot of sysadmin work with them. And we have people coming into the Ruby community and they're saying, well, you know, we're a business, we've got a Rails project, we'd love to get some. Do you know any freelancers? Man with the hat. And I'd say they've all been sucked up for now. So it can be harder to find, certainly find people, but one of the things we're hoping to do is bring more people on board. And the more popular the framework gets and the more popular the language gets, the more people there will be in the
But what about the desire to learn? So, okay, I'm currently, I understand framework X or language Y, and I want to learn something new. Certainly, my perception is that the edge is for Ruby at the moment.
Yeah, quite possibly. So I think this is something that'll be. I think one of the things that's happened in Ireland is there's been a little bit of a lag with the rest of the other tech centres in the world. I mean, right now I think there's a phenomenal amount of really cool startups and companies and a lot of tech innovation in Ireland that's coming through. We've probably traditionally lagged, and I think that, in terms of numbers, we've got like .NET and Java developers 10 a penny. We probably don't have so many Python guys, and we don't have so many Ruby guys, and we've got 1 or 2 Node.js guys. But I think it's coming through. It's something that's catching up. The more startups are using, the more it's filtering through, and the more, I suppose, there's going to be a lot of initiatives also to target young people and younger audiences in terms of what languages they use, and we probably see then really, what kind of languages people want to learn. I think it's something on the horizon.
Richard, tell us about the popularity of Node.
Yeah, my world is, I'm kind of like the Christian martyr going to Emperor, well, not Constantine, one of the early guys, and saying, don't throw me to the lions. I suppose the challenge with Node is, if you believe in it, if you think it's really cool, you still have a job convincing clients. There are a load of startups that are using it. That's a great place if you want to do Node, and there are a couple of big companies. But yeah, I mean, it's still, the wave is still cresting. So there's a challenge there. It's once you start using it, it becomes apparent that it's going to be pretty cool. But I've been out pitching for jobs and lost them because people are like, well, I'm not using some weird, funky new technology. But it's starting to prove itself, and I think it's where Ruby was a couple of years back for sure.
Can I throw it up in the audience? Can people show of hands who uses Node today as their main programming language? Okay, that's pretty conclusive. And what about Ruby on Rails? Okay, and Python? And quick poll, who left in the audience uses Java still? Okay, so what are the rest of you guys using? PHP? Yeah, I mean, it seems to be a pretty fragmented marketplace, certainly in this audience. So I don't think there's any clear-cut winners in this. So let me ask you a different question. This will be the last question for the panel, and then I'm going to take questions from the audience. Okay, we all know that our favorite programming language and framework is the best in the world, but what about when you want to call legacy code from other systems? How do you handle that in your various different frameworks and approaches?
Python's extremely good at that. There are implementations for all the main virtual machines. The Windows integration is legendary. It's always been fantastic. The integration with the JVM, literally the barriers, there are no barriers between Python code and Java code. Foreign function interface support, if you want to call Fortran libraries. There's the story is very well understood, has been for a long time.
Okay, Declan?
I think probably one of the big ones is like Alan was saying, in terms of Ruby, you have JRuby, which gives you that whole suite of libraries that are in Java. A lot of the places, to be honest, I see Ruby used as a glue language where you're calling other things. Usually you maybe do a system call on a Linux box to do something, and there's nice ways to pull the output out of that. But obviously then you've gone outside your process, so things like error handling can be a bit more tricky. But generally in terms, it's pretty much a similar story. That the Ruby language is implemented in those other languages.
Now, I'm hearing a little bit of fudge there. Does that mean you can't natively link in Ruby to an external library?
I actually don't know. It's not something I've used, but I do know that we had a talk from Ruby Ireland where people were doing that and doing a lot of marshalling in and out of the C through a particular interop way, but I'm not sure. I personally don't use that much myself, so if maybe someone else of the small but significant Ruby community here knows, then
and Richard,
jump in.
I think the nice thing about Node is because it's based on the Chrome V8 engine, which was designed in the first place to be embeddable. It's actually really easy to squeeze it into things. So it actually runs on a bunch of mobile phones. It's written in C and C++, so you can always kind of drop down to that level if you really need to do something difficult. My preferred way, to be honest with you, is talk over the network, if you at all can.
Bah.
Yeah, you haven't programmed infrared cameras.
Can I maybe see if there's any questions from the audience about
one thing I should probably mention is that like a lot of gyms are C-based, so there's interop with C there. But again, I'm out in my area of expertise on that.
A mic that we can throw down to the audience. Maybe you can dash around there, make yourself useful. So sorry, show of hands. Who's there? There you go. Man at the front. We'll work our way front to back. Right here.
Look over. Thanks, Joe. So my question is, and it comes into the popularity part of it. You said that there's loads of Java programmers, loads of C# programmers, Microsoft programmers. I've been doing quite a number of interviews for student work placements and internships at my startup, looking particularly for Ruby, bit of Python, bit of Node. All that stuff would be great. I haven't found anybody that has even looked at that yet. And maybe I'm getting the wrong people in, but drilling down into the courses that are being taught, there's nothing of that nature. They haven't heard of dynamic languages. Well, there's bigger problems. They haven't heard of source code control either. But there's some real difficulties within the education of the current third level education. Now, there's a whole topic of teaching people these kind of languages, which I think are easier to learn than getting in and doing Java and having to get your head shoehorned into Maven and all that kind of gear. So, do you see any kind of way that we could popularize these languages within, or evangelize these kind of languages within the university courses or outside them?
Sounds like one for you, Richard.
So, funny you should say. I am actually about to start lecturing a one-semester course in WIT starting in January on Nodejs. So, come talk to me in the summer. I think it is starting to move, and there are people in the academic community who keep an eye on this stuff and try to move forward each year. I think there's a huge force on the system to keep producing Java grads and .NET grads and that sort of thing. But I think if you look for change, you will find it. It is starting to happen.
I think historically computer science courses have been very focused on the mathematics of the language and the algorithms, and tend not to focus on the nuts and bolts of actually producing a product for sale. And that's a real gap, and it's always been so. I mean, when C was all the rage, I was learning Ada.
You also see that universities will also follow the money. So if, for example, a government decides to back cloud computing, they immediately offer huge cloud computing courses where you can program your cloud in Java, and they'll teach you how to build data centers because they'll go for the whole hog. But I know what you mean. But there's room in between these other ecosystems, the Java ecosystem, the Microsoft language ecosystem. There's room for more in there. So I suppose it's trying to get that in.
This is something that comes up regularly every year. Python Ireland, we're always talking about how can we increase awareness of the language. You know, it is a teaching language. That's what it was designed for. So, you know, there's a very strong argument to be made, be it JavaScript or Ruby or Python, that, you know, a simple language that isn't putting so much such a steep learning curve in front of the students would be much better for them in the long run. Maybe they start off with Python or Ruby and move on to Java. But the other side of it is, you know, from the academics' point of view, not only is the demand from industry coming that they supply Java programmers and .NET programmers, there's also the problem that they might actually, if a lecturer decides to teach a course in Python, when the syllabus said Java and the student doesn't do well, that's the lecturer's fault, not the student's fault. But there are, as Richard says, there are bright notes. Paul Barry, based in Carlow IT, has written a book on computer science in Python, and is very much leading that charge. So, what's the name of Paul's book? Head First Python. So,
Okay.
Maybe I'll just jump on that quickly. Just one quick sentence. Okay. Just in terms of, it's always going to take a while to move academic institutions on, and really the way Java became big in academic institutions was because it actually went and it was big in the market. So I think I'd always have, you know, one eye and a bit of sympathy towards the private enterprise. I think when the big startups come through, the Pythons, the Nodejs, and the Rubies, you're going to have much bigger volume of noise and much more demand, because that will drive people to move forward. So, and I think that Ireland's somewhere that's going to happen, because we all know we're all here, and a lot of us are doing startups and things like that in that direction.
Okay, Richard mentioned the dreaded 4 a.m. phone call. Can you all give us a brief comment on how your preferred technology helps build reliable systems that won't page you so often at 4 a.m.?
I'll jump in on that. You know, it's all about exception handling. If you're not doing exception handling, then you're not handling exceptions, and you're getting phone calls at 4 o'clock in the morning because there's a stack trace on a console window, and either some computer spotted it or some human spotted it, and you've got to fix it. I think JavaScript's only developed exceptions about halfway through its life. Started around 2002, 2003, whereas exceptions are core to Python's design. So, if you design your code properly with the proper exception hierarchy, then, you should never see those things.
Java had no bugs before then.
Bugs.
There's no bugs in pseudocode.
So, does that answer the question? Is that what you were trying to get at? That applies to all dynamic languages. Coverage, if you're concerned about that kind of thing, use a coverage tool to be sure that you have actually executed every line of code.
And just on that point, actually, I think it's the chap in the team that are writing Go and Google are pushing that forward. The head designer there, I think he's got papers published on the biggest cause, I think, of vulnerabilities and bugs in Java is the type system. And actually, one of the things when they've been evangelizing, I can't remember sorry, is it Go or the other one, Dart. I always mix these two up, but hey. But whichever language it is, they said basically the type system was what introduced an awful lot of vulnerabilities. And when you get rid of that, you have less vulnerabilities. And yes, you can cover it by other methods like tests. And in terms of avoiding the 4 a.m. call, the best chance you can give yourself is to have a good amount of appropriate test coverage in place, and then you're less likely to get those phone calls.
So I would subscribe to a completely different approach, right, which is crash-first programming, which means that if something goes wrong, you just crash and restart. Right? And actually, that is a really good proven model. If you look at Erlang, which is designed to run 5 nines telecom systems, that is exactly what it does. If an Erlang process goes funny, kill it and restart. And the cool thing about Node is it's kind of designed to do that. It has a sort of 20 to 50 millisecond startup time compared to Java, for example, or anything else. That's really cool. You just kill it and restart, kill it, restart, kill it, restart. One of those high-profile sites that I launched recently, due to overzealous attempt at caching, had a huge memory leak. And if you look at the memory usage, it went bang, bang, die. All the virtual machines and all the node processors were dying every 15 minutes. I didn't notice. The client didn't notice. None of the users noticed. I mean, literally, right? The way that site works is it loads a single static index.html and does a bunch of JSON requests, right? JSON request, server crash, JSON request, it just keeps working. And that's really cool. That really fast startup time saves your ass. And I didn't get the 4 a.m. phone call, so.
Yeah, I think in general, you're not going to save your life by picking a particular programming language. The trick is not to be the person that gets that call. Okay, we've got more questions from the audience. There's a man with his hand up down the back.
Just following on your point earlier, Joe, and actually on this topic, and somewhat relevant as we're looking at a Chrome window, going to RFC 2616 and HTTP pipelining and looking at new protocols like Speedy, because Googler have already released figures saying that's where you find 66% speed up if you dump TCP and look at different network protocols, because at the back end you're going to be caught until you can, in essence, paralyze those requests. So how do the different frameworks support HTTP pipelining?
Who wants to take that one?
So I'll take that first, right? I don't actually know, but because it's based on Chrome, I think Node will pretty much just piggyback on whatever Google does with Chrome. So that solves the problem for me, to be honest with you.
And my response to that will probably be one of ignorance as well. I don't know the nuts and bolts, but what I do know is the Rails 3.1 brought in the ACID pipelining. And what's that? Okay, so is what you're telling me that Ruby's cool with this?
Yeah.
Ah, cheers. So Ruby is really strong over Node.js, and this should have started with that.
I just add to WSGI makes that's a container concern. It's not an application concern. So how the input body comes in, how the response body goes out, that's all a factor whether you're using Apache or Tomcat or your own little Python server or whatever it happens to be, and whether a particular framework implements it may vary across containers. You may find that it'll work, if Django supports it, it'll work perhaps on Apache with mod WSGI, whereas it mightn't work if you're running a WSGI ref server. So that's really a server-oriented concern. But I mean, in terms of actually servicing multiple requests, lots of web servers do that. So I don't think it's an important performance concern, but it's something that doesn't really belong at being exposed, I think, to the web application. It should be taken care of inside the framework.
Okay. Maybe we'll take one more question and then we'll try and wrap it up. Okay, cool. Okay, let's keep going. Let's keep going.
Hi, I actually have more experience in Perl and PHP, and I'm just wondering, it looks like there is one language and another language and another language, so do you have to decide and scrap your code and first learn completely new, or you can take part of your code and move it slowly? Like I have a nice code and I can take Ruby and I embed it and start using features from Ruby, and maybe in 5 years there is a cool feature from Python and I want to use that, but I'm already stuck with Ruby. So how the language are friendly towards others and towards compatibility and usability of other codes?
But I think that was kind of similar to Joe's question around can you call other languages from within one language. So in terms of compatibility, I think that's pretty much the answer I've given that one. But around things like portability between languages, like I suppose it depends how much you use the more esoteric features of that particular language. So we know in Perl or in Ruby you can write very condensed code that can be very unreadable. It's going to be a struggle to translate that into Python. But I think for most things in Ruby, because of the similarities to Python, and I've done a little bit of both, obviously a little bit more Ruby, that I don't find it difficult to understand Python to at least translate code. And it's often interesting to compare the different techniques in each language. I'm not sure if that's answered your question, but I don't know whether you can translate automatically. There might be something out there, but I wouldn't say.
There's nothing to automatically translate Perl. It's called a human being.
That's kind of a complicated question in that really it requires a common execution environment to be able to run multiple interpreters under that same environment. If you were working on the JVM, you could do that quite easily, actually. You could run Python, JRuby, and JavaScript all within the same process and be able to, I mean, at the end of the day, if you read the WSGI spec, you'll see that, a web application is just a stream and a set of name value pairs and URI going in and a response body of bytes going out. So if you can, at that level, split up your web functionality across multiple languages, it can be done. Same can be done on Microsoft's .NET platform. But when it comes to taking interpreters and banging them together, I mean, there's been several efforts in that world where people who didn't like Python would take the CPython interpreter and link it with the Java JVM and run code and make calls back and forth. But it gives rise to huge numbers of problems with garbage collection, particularly because there are different garbage collection strategies between the two VMs. So who owns information as it passes between the barriers is quite a knotty little problem. One thing that I didn't get to cover was on my last slide, and really I think the future of all of this stuff is where the linkage between our applications is going to be network protocol oriented. So we're going to be sending JSON documents and Atom documents back and forth to communicate between our applications. And that's the way that I think we're going to achieve the kind of using multiple implementation technologies to come up with a unified front-end application.
I mean, I think in practical terms, that's essentially the solution. I would also say you've got to have a sort of a Zen approach to this, right? Because, like, I had 10 years of Java code that I've just let go. I'm actually not that happy, to be honest with you. And I suppose the advantage I would see in choosing JavaScript is you already have to use it for the web. You already kind of know it, so there's less work to do.
Okay. The one thing, if you do find an automatic translator between any of these languages, probably a lot of the more common things will be easy to translate, but there's always going to be those functions that nobody touches, even the people that actually work in that company. And if you run an automatic translator on those ones, you might get some interesting results and a few 4 a.m. phone calls as well. So.
The problem with automatic translators, way back in my day, I worked for Digital Equipment Corporation, and they automatically translated all of their VAX VMS assembly language to Alpha. And it meant that they ended up with an operating system for which they had no source code. Not a good place to be.
This question specifically for Richard, is it?
Yeah.
There's 3 letters that I noticed you didn't say during your talk, and it's MVC. So,
I'll take that one.
Yeah, so I'm wondering what sort of frameworks and libraries are you using for the likes of routes and templates and...
Okay, so the one of the weaknesses of the Node community and ecosystem at the moment is there's kind of a pitched battle between lots and lots of different frameworks, and a lot of them are kind of half-baked. You should check out Railway.js, which is pretty much a clone of Rails. It's a good place to start. The other side of that coin is Connect and Express. They are pretty good modules. To be honest with you, I've kind of abandoned the MVC model that crosses over onto the server. So my approach these days is serve up some static HTML and just do JSON backwards and forwards. And then on the client side, you're looking at using something like Backbone or Knockout to do your MVC, right? And the server is just routes, basically, that throw back JSON. It's much more client side, yeah. It's much more, I suppose, the original MVC from back in the day, right?
Okay. Kenneth. Hey.
Java.
COBOL.
I'm the guy wearing the suit, so.
I think all programmers in Ireland can earn pretty substantial sums of money these days. They're in demand. We're very lucky to be in a boom economy for technologists. Okay, the man down the back with a microphone.
Great. One of the observations I've made in the past with new and upcoming languages and frameworks is that when they become popular, they eventually become legacy languages and frameworks. And when they become at that stage, there's a lot of code that you wind up having to support and maintain. My experiences of maintaining JavaScript, PHP, etc., hasn't generally been a pleasant experience. Of your 3 languages, which one would you say is the least friendly to support in, say, 5 years' time, someone else's code? Or are they all equally perfect? And if I pick up your language...
I'd have to admit that if a gun was put to my head, I would actually choose Python in terms of maintainability. And that's going from personal experience. On the other hand, of all those languages, the one least likely to become a legacy language has to be JavaScript, because we're kind of stuck with it. Right?
You still have to maintain it, though, even if it isn't what you call legacy. It still generates a lot of code and JavaScript is pretty awful at times as well.
That's why I'm choosing Python. There's two senses of legacy, right? There's global legacy where you're looking at stuff like, I don't know, Prolog or Ada or something like that nobody really uses anymore, and then there's legacy because your company built something 5 years ago.
I think just on the side of maintaining stuff, and it's true, I'm sure, of all the languages here, that they all follow conventions. One of the things that we lacked before Rails was actually following conventions, and instead of having 3 million XML files and configuring them and lots and lots of deep class hierarchies, which I've often found more difficult to pull apart than anything in a dynamic language. I think the two best things in terms of mitigating issues around maintainability is having good tests, because they don't just keep your system straight, they actually document your system. And that's one important place, and all languages are strong in that. And the second thing then is the use of conventions and a pretty tidy language. And I think that, the three languages out, certainly Python, I don't know as much about Node.js, but I wouldn't think there's that much in between it, as long as you've got pretty decent developers. So.
I suppose I'd add that Python has a very vibrant developer community. There's multiple implementations, the most interesting of which is PyPy, Python written in Python, which is achieving amazing performance results at the cost of significant memory use. But it's pretty amazing, pretty fast. So, and that's only beginning to roll out now as an interpreter technology that will be widely used. I suppose in terms of writing web applications, we don't have a direct comparison here, because I'm talking about a language that has a load of frameworks, and Declan's talking about a language that has a load of frameworks, with Rails obviously being the primary one. And then we're comparing with just one framework on one virtual machine, which is like, it's not a direct comparison really. I mean, to me, server-side JavaScript would be running Rhino inside Tomcat. That's also server-side JavaScript. I think I'd be a little bit concerned about Node that they don't fracture too much, and if the templating story or the routing story or the ORM story is being fractured, then it doesn't come together as an integrated framework. Then you might be looking at rewriting a lot of stuff over the years.
And I think one of the things around that actually is a good point, the fracturing. There could have been a fourth person sitting here today. This isn't going to be sad, don't worry. But there did come a point a year or two ago where a lot of people, because Ruby people are fairly petulant, half of them have actually jumped over to Node.js as well, which just right royally annoys me. But the MERB came up and as a big competitor, and a lot of people jumped on MERB because it was a counterculture to what was the Rails culture, and you already had a lot of angry people. So thankfully one of the good things is that it's actually all come back together, and a lot of the MERB features have been pulled into Rails, and you've got the MERB core people contributing to Rails, and avoiding, if there is a second or third splinter in the Node.js community, if they can avoid the fracture, bring it back together and all get on, it's probably one of those crucial things to keep it moving along, I think.
Okay, we've got two more questions from a gentleman here and a gentleman in the front row, and then I think we'll wrap it up after that.
Okay, in the Python presentation, we've seen some terms like cross-site scripting, cross-site request forgery, SQL injection, and session fixation. In terms of security terms, how Ruby and Node.js address those problems?
So yeah, there's cross-site request forgery protection in Rails. You've got parameterized queries in Rails, so you can avoid against things like SQL injection. If you use the Rails syntax for querying, you automatically always get SQL injection protection. SQL injection is kind of tricky sometimes because it depends on what kind of query you're building. So I don't want to go into details of that, but guarding against an insert statement from a select statement, things like that. So that's those two aspects, and the other two were cross-site SQL injection and yeah, again, all of those are covered. I think all the frameworks pretty much, because again they're open source languages. As soon as one framework makes a dash in one direction, if it's a particularly good thing, you start seeing the feature jump into the other framework. So all those things are covered, and probably the strongest reason and the reason it will come into anything is that they're all open source and they're looking at each other every day.
With Node, I suppose one of the ways you protect yourself is when you're building a Node app, you tend not to use SQL. You tend to opt for one of the NoSQL systems like MongoDB or Couch or something like that. So you're exchanging JSON documents anyway. And then when it gets to server side and you're inserting them into a MongoDB database, there's no real opportunities for injection in any case, because the JSON is either valid declarative syntax or not. Whereas SQL is a language that does stuff. So you tend to be a lot safer in that sense. But the other frameworks would have more developed protections against cross-site scripting and that sort of stuff for sure. And it comes back to the fact that there's clear winners for the other two languages, and that means that there's been a body of work done on them to cover all those edge cases. You're still flying a little bit by the seat of your pants with Node when it comes to that sort of stuff.
Okay, last question. We'll
Hi.
pop at that point.
There's something sort of a strand to discussion today that worries me a little bit. Like when we were talking about Node.js there, one of the compelling reasons that was cited to use it is because there's a good runtime environment available for it, a fast runtime environment available for it. And while that makes sense from a practical point of view, it's kind of worrying that we're choosing our language in which to kind of go back to the maintainability question, which we're going to start building this very large code base in just because there's a good runtime environment for it. And I guess kind of my issue here is that in this discussion today, we're coupling the style of web framework that's available currently to a decision on what language to use. And we're not really thinking so much about whether a language is semantically clean. Like, there's no doubt at all that Ruby on Rails is a very productive environment in which to use. But Rails being productive is driving adoption of Ruby, which is maybe, you know, whether Ruby is the best language for us to be building large amounts of code in is a different question. And there's bits about Rails, like Declan mentioned 1.minute.ago or whatever it is. Like that, in some sense, that's very scary. Like, why does oneness need to know at a class level about minuteness and ago-ness? Like, that's available, particularly these big language choices are going to last into the future. At some point of view, from an engineering point of view, we're sort of doing stuff wrong, I think, at some level. What do you guys think about that? Is that a fair opinion, or is?
Well, I just like to jump on the first point about, you know, the speed of the runtime being a deciding factor. I think the fast runtime provides the opportunity to innovate on top of that. So I wouldn't be worried about the fact that you know, Node.js is being used. I don't mean to answer your question around that, jump in, but I wouldn't be concerned about that because in terms, like, what's the alternative to close your eyes to innovation and a really good solution to business problems because of some fears, you know, that it's not the same as everything you already know. On the Ruby side, it's just it's a matter of style. Metaprogramming comes in really useful for an awful lot of things. If you've used generics in Java and or .NET, and they really you hit a point where, you know, it's just horrible. In a lot of applications, generic soup, a lot of people are familiar with it. And then actually duck typing seems like a much safer, saner approach to actually use and have some unit tests around it. I would definitely argue that the Ruby syntax is incredibly clean, and I think Python's is as well, and you know, JavaScript. I think it's probably not as clean, but there's always CoffeeScript, and I'd certainly dispute that. Like, I think, you know, Ruby is exceptionally, you know, beautiful, elegant, and clean language to use. And in terms of what you call monkey patching and 1 minute ago, again, it comes back to conventions. If something is open source, it's different to something that's closed. If you've got a vibrant community where everyone is aware and everyone is touching base with each other and everyone can see what's happening, it's not as big a problem because it becomes a de facto standard. People know that's what Rails brings. And a lot of the innovations that come through in Ruby have actually started to come from Rails, where features come into Rails at a grassroots level where people bring in a feature, and then that rolls into Ruby later on. And you can always choose not to pull in Rails.
I suppose I'd say, in some ways, premature optimization is the wrong approach. You know, worrying about the execution environment is not something perhaps that you should worry about. The other side of it is that a design architecture can have an enormous impact on how your service scales. And Node.js being event-driven, like Python's Twisted, that's going to be able to scale you up to maybe 10, 20,000, 30,000 simultaneous users on an individual machine. But then, which you'll never achieve with a threaded architecture on a single machine. But load balancers, software load balancers in Amazon are relatively cheap. Micro instances are relatively cheap, so maybe just run 10 small instances, and running a threaded environment can save you the programmer time necessary to get your head around the complexity of doing event-driven systems. I suppose Python's got the widest story in relation to possible execution environments. There's just a good number of high-quality interpreters in radically different virtual machines that you can choose. But I suppose my approach to problems like that would always be address the performance problem when you have a performance problem. And don't worry about it until you do.
I guess I'd have to say I'm kind of unashamedly pragmatic in the sense that we're kind of stuck with the way things have happened. I mean, we're using an IBM CPU architecture that is plainly nuts and should have been thrown out years ago, but we're stuck with it. So in the sense that if you want to get stuff done right now, I think you have to look at those options and see what suits you and what way the technology industry is going to go. I mean, you could be like what's his name, Paul Graham, and his 100-year language. And if you use this website, you'll notice that like if you get down to the bottom after about 5 minutes, you press the next button and it breaks. It's really hard, right? And JavaScript has warts all over it, and Ruby and Python do. And as programmers, we always like to throw everything out and start again. But at the same time, I think you kind of have to pay the mortgage and eat. So I don't think it's that bad. I think in a way you just have to kind of suck it up and just use it.
Okay. I'd like to thank all of our panelists. I think we got a pretty good overview of the languages there. I mean, Declan told us that Ruby on Rails is awesome, and also showed us that Prezi is probably not the best tool to use for doing presentations. Alan told us about Python and how it had the best standard support of any language in the world, forever and ever. And we got a very good, interesting insight into Node, and basically we understand that Node programs crash all the time from Richard. So we've learned a lot tonight. My own perspective is the best programming framework to use is the one you're using at the moment. Change is generally not a good thing. You'll be more productive using the thing you're using right now. It's important to understand what's out there. The new thing has costs, and I think Richard demonstrated them. And the older and mature programs, I mean, I think if we come back in history, we'll see Ruby on Rails is getting lots of good stuff coming up down the line. Python, because of its age, has scads of support for every library and framework under the sun, but the actual virtual machine is pretty sluggish at the moment because it's quite old. My personal preference has always been Python, but I think you should look at the other technologies. And my understanding at the moment, everybody that comes to me that's looking to write programs wants to write them in Ruby on Rails, and that's an important aspect for what you're doing in the future, popularity. So maybe put your hands together for the panelists, and I'll hand you over to Sean to.
And put your hands together for Joe, I guess. Well done, Joe. Thanks. So as you all saw, I'm sure, with the agenda behind the speakers, we've a completely straight agenda. I'm not going to hold people here much longer. We just, on the fly, decided to drop the Google Developer Day stuff. I did put a post on the GTUG blog about Google Developer Day, so if anybody's interested, you can have a read of that, or you can ask me some questions. I had a few announcements to make, but I can't remember all of them off the top of my head. So they were just various events that are going on in the future, just because I knew we'd have a fairly big crowd here, so I thought might take the opportunity to notify people. On the next session of the Dublin GTUG front, I think we're going to for the first time in a year and a half, we're going to skip one in December because it's a Tuesday in December is bank holiday just after Christmas Day, and we hadn't got anything specifically lined up for it. So that means we're going to have the next one at the end of January. I think it's the 31st of January. It's there's a Google DevRel guy, developer relations guy. Sam Dutton is the guy's name. He's a Chrome HTML5 guy. Do you know what he's going to talk about specifically, Gene? So development in Chrome, is it? Yeah. Okay, so he gives talks on development in Chrome, and he's going to be probably talking about that. There's a likelihood that we'll have a guy from, I think, Trinity and talk about linked data stuff as well. So that's, I think, the last day in January. So it's 8:30, so as usual, after these sessions, we're going to go down to the schoolhouse just on, I think, somewhere Hampton Road for a pint or two. So you're all welcome to come down and have a pint with us. So I'll leave it at that. So thanks very much, guys.